Welcome back. In the last session we started third oscillator, but I didn't name it. I'll name it after completing this. Then I told that we are going to consider op-amp or amplifier output impedance. That should be considered because now the load doesn't have any resistor, that is for sure, because to decrease the loss by beta network. Then we should consider the output resistance. Now including output resistance and the load, we need to calculate effective gain, and I told that the effective gain is calculated considering RL interaction. Then we got effective gain is nothing but RL divided by RL plus R0 into the no load gain, whatever gain, which is what people are expressing, saying that this is what is the gain by your op-amp. Okay, therefore tell me what is this. Therefore this is also nothing but what, if can I write the same circuit like this? This is what your open loop amplifier A, right? And then whatever it is connected at the output of your amplifier is nothing but ZL. Therefore can I take it as ZL effectively, just to calculate. Therefore heading is to calculate effective gain, to calculate A star. A star is nothing but effective gain. That is what I told there. Okay, therefore this is nothing but ZL, right? Therefore this is nothing but your output V0, this is your V0, let us say, and this is what your Vi. Actually that Vi is coming, whatever maybe I am speaking with respect to amplifier. This is what it is, and it has output impedance, right? Then same as that, if I use it, then tell me what is A star. We know that A star effective gain is equal to your overall gain A, no load gain, into, which is already given, A into ZL divided by ZL plus R0, where R0 is your amplifier output impedance, where R0 is your amplifier output impedance. Okay, your output impedance is nothing but, it is effectively represented, therefore output impedance of your amplifier is nothing but your R0, right? Now tell me, if R0 is 0 or R0 is not comparable with respect to ZL, then if R0 is 0, then it is simply A. Your effective gain is number A. That is what we have taken in the case of RC phase shift oscillator and wind bridge oscillator. But here we are considering because R0 is comparable with ZL. Now, if you do that, what is ZL first of all? Where ZL is nothing but, what is ZL? This is the load. Z1, Z2 in series, that is in parallel to Z3. Therefore, where is ZL? What is ZL? Where ZL, what is ZL? ZL is equal to Z1, Z2, that is in series, Z1 plus Z2 into Z3 divided by Z1 plus Z2 plus Z3, right? This is nothing but Z1, this is nothing but a parallel combination. This in parallel to this is nothing but Z1 in series to Z2 with respect to your amplifier, because the current entering into your op-amp is 0. If current entering into your op-amp is equal to 0, remember, then you can ignore this branch, then simply Z1, Z2 will be in series. For example, if there is a current entering into your amplifier, then we have to consider input impedance of amplifier, that will be coming in parallel to Z2, that is in series to Z1, that is in parallel to Z3. That is what we need to calculate. That is nothing but your effective ZL. Okay, fine. But now the Z2 and then in parallel to input impedance infinity, because I am just assuming that this amplifier is having input impedance very high, neglecting it. Therefore now, if that is the scenario, you substitute. Then what is your A star? Therefore your A star is equal to, okay, you keep it like this. This is what your A star. Now we know A star, then we want to know beta. Therefore we got to know effective gain to calculate beta. This is what you can call it as equation 1, and you can call this ZL as star. Now to calculate beta, right? What is beta? Beta is nothing but therefore this is what is your network, right? Beta network. This is Z1, this is Z2, and this is Z3. And this is what is output, right? Let us say this is what your output and this is what is your input, right? This is what is input. This is your input. Therefore, what is your beta? Beta is nothing but your output by input. Let us say this is your output and this is your input. You can say like that. That is better. Okay. Then output by input. Therefore, output by input. Therefore, what is output by input? Here, Z2 divided by, it is simply Z2 divided by Z1 plus Z2. Even though it is in parallel, doesn't matter because that is in parallel to your input voltage. Let us say that is in parallel to Z is nothing but voltage only. I already told voltage source in parallel to a resistor. Voltage source only. Therefore, no need to consider about this to find beta. Therefore, whatever you are having the voltage across Z2 with respect to the input voltage, what you have, that is nothing but your output voltage. That is what you are feeding back to your amplifier. Therefore, Z2 divided by Z1 plus Z2. Therefore, we got to know beta also. Therefore, this is what is your beta equation 2. Now, from 1 and 2, let's calculate effectively which is your A star into beta, which is nothing but your loop gain, right? Then A star into beta should be ultimately 1. The total loop phase shift must be equal to 0 degrees and the total loop gain must be equal to 1. Okay? Take it. Then we will multiply or we will take product which is A star into beta. Then let's have the observations. Then we will, this is also over. Then I will name the circuit. Okay? Done. Okay, now if you see what is A star beta, therefore we want to calculate A star into beta. Therefore, what is A star into beta? Therefore, A star into beta, this is what is our total loop gain. A star beta is nothing but your total loop gain. Total loop gain is equal to, what is A star? A into ZL divided by ZL plus R0 into beta. Beta is nothing but Z2 divided by Z1 plus Z2. Now we need to substitute, it will become bigger expression, what it may be. We need to substitute ZL in this equation, then we need to get A star beta ultimately equal to 1. Having total loop phase shift 0 degrees and total loop gain is equal to 1. Right? Therefore A star beta is equal to A into ZL. What is ZL? Z1 plus Z2 into Z3 divided by Z1 plus Z2 plus Z3, right? That is what is ZL divided by Z1 plus Z2 into Z3 divided by Z1 plus Z2 plus Z3 plus R0. This is what your R0, right? Into Z2 divided by Z1 plus Z2, right? Z1 plus Z2. If you take Z1 plus Z2 plus Z3 LCM, then what you get is equal to A into, if you take then Z1 plus Z2 plus Z2 will be cancelled. Then what you get? You will get Z1 plus Z2 into Z3 divided by then Z1 plus Z2 into Z3, Z1 plus Z2 into just mathematical calculation, Z3 plus into R0. Therefore, R0 into Z1 plus Z2 plus Z3, right? Into Z2 divided by Z1 plus Z2, Z1 plus Z2. I think Z1 plus Z2 and Z1 plus Z2 that will be cancelled. Then it is simply A into Z2 Z3 divided by Z1 plus Z2 into Z3 plus R0 into Z1 plus Z2 plus Z3. This is what is the equation after substituting everything, considering the output impedance of your op-amp, right? This is what it is, okay? Therefore, this is Z2 Z3 by Z1 plus Z2 into Z3 plus R0 into Z1 plus Z2 plus Z3, okay? Now, I told you we don't want to use any resistor in beta network. Then only the loss by beta network is minimum. I want to use reactive elements like inductors and capacitors, right? If I use only reactive elements, then therefore if I use only reactive elements, combination of reactive elements we need to use such that the total phase shift should be equal to 0 degrees, that should be satisfied. Therefore, if you substitute mathematically, you will get that condition, right? Therefore, that's what I am saying. This is what your A star beta, okay? Let Z1 is equal to J into X1. What is the meaning of J into X1? It is a reactive component. If X1 is positive, inductor. If X1 is negative, capacitor. That is the meaning of it, okay? And Z2, but no resistor, okay? Z2 is equal to J into X2 and Z3 is equal to J into X3. Now can you substitute? Therefore, that depends on X1. X1 positive means inductor, X1 negative means capacitor, okay? Now if you substitute, what you get? Therefore, A star into beta, the effective gain, is equal to A into, what is Z2 Z3? J into J. Therefore, you will get minus X2 X3 divided by Z1 plus Z2, X1 plus X2 into J into X3. Therefore, J into J minus, then you will get X1 plus X2 minus into X3 plus, if you take J common, therefore you will get R0 into X1 plus X2 plus X3. This is what we get, right? This is into, okay? Therefore, now if you remember, I want to make it independent of J, complete loop gain. I don't want to have any phase shift. I want to have 0 degrees phase shift. I want to have 0 degrees phase shift because this is what is my complete loop gain. This is what is my complete loop gain. It should have total loop phase shift is equal to 0 degrees or multiple of 2 pi, and total loop gain must be equal to unity. That is secondary condition. The primary condition is nothing but what? It should have 0 degrees phase shift. It should not have any J term. To do not see any J term, what is the condition? The condition is if X1 plus X2 plus X3 is equal to 0, then it will be independent of J. This will be cancelled. X3 will be cancelled. Then you will get X2 divided by X1 plus X2. Minus also minus will be cancelled. So you will get X2 divided by X1 plus X2. You got it? Okay? Just write down. Then we will see the remaining part. We got loop gain. Then we can have the observations to satisfy Barkhausen criteria. Okay? Now we can use Barkhausen criteria. And then let's apply the conditions to get oscillations. Okay? Then we will get it. I'll give you 30 seconds, then we'll continue because I'm going to rub it. To make total loop gain independent of J term to get 0 degrees, not 180 degrees, because this is total loop gain, 0 degrees phase shift. Okay, this is the heading. Therefore, what is the condition? Condition is x1 plus x2 plus x3 is equal to 0. This is the condition. Okay, that condition will give you resonant frequency. That part we will see later, right? But that is the condition. Therefore, what is A star beta? Therefore, A star beta is equal to, when you substitute, what you will get? That is A into, right, minus x2 x3 minus x2 x3 divided by, right, minus x1 plus x2 into x3, right? Then x3 will be cancelled, minus will be cancelled. It is simply A into x2 divided by x1 plus x2. x1 plus x2. If you observe clearly, what is x1 plus x2? x1 plus x2 is nothing but minus x3. That is minus x3. Therefore, this is nothing but A into, right, minus, therefore you can take it that minus outside, minus A into x2 divided by x3. This is what we get. This is what is our total loop gain. A star into beta is equal to x2 by x3, right? Therefore, now tell me, what is the observation? This is done. Now, what is the observation? This is important. The observation is, we want it should be 0 degrees. It should be 0 degrees. And if you see x2, x3, what is x2, x3? This is what is related to Z2, Z3, right? Then x1 plus x2 plus x3 is equal to 0, right? If you say x2, x3 are alike elements means either x2, x3 are inductors or x2, x3 capacitors. If x2, x3 are alike elements, then both will be cancelled. There is no phase shift. Then this is what is having minus A. Then A should have, this is 180 degrees. Then A should have 180 degrees. Therefore, this should give 180 degrees and this is 180 degrees. Overall loop phase shift will be 0 degrees. That is what we need for oscillations. Therefore, if you consider x2, x3 are alike elements, you may say, I can take x2 inductor, x3 capacitor. If you take xt inductor and x3 capacitor, right? But we should know, if you take it, then x1 plus x2 will be opposite, right? What do you mean by x1 plus x2 opposite? Because when you take x2 x3 opposite, then let us say x3 is equal to minus of x1 plus x2. Then x1 x2, if you say alike elements, if you say x1 x2 alike elements, therefore x2 alike elements, x3 is opposite, right? In that case, if you calculate, then minus will be cancelled. Then what you get? You will get A, but something will be wrong. I'll explain that part. Okay. Now let me couple it, then I'll come back to the other condition. We have two solutions, whatever may be, right? Now, if that's what, if x2 and x3 are alike elements, in the sense either inductors or capacitors. Okay. Then let's see example, case A, right? Alike elements means inductors. Therefore, x2 and x3, they are inductors. When they are inductors, then tell me, what is x2? x2 will be what? S into L. Therefore, I can write in omega also. Omega is also fine. Therefore, omega into L2. Then what is x3? x3 will be omega into L3. Then if x2, x3 are inductors, then what about x1? This is what star is already used. What is the equation 1 and 2? Let us say this is equation 3, right? Then 3 implies what is your x1? x1 is equal to exactly minus x1, x2 plus x3. If x2, x3 are alike elements, right? Then both are inductors. Then what is your x1? It is negative. Therefore, x1 is capacitor. x1 is capacitor. It should be capacitor. If x2, x3 are alike elements, are inductors, then omega L2, omega L3 minus. Therefore, your x1 should be capacitor. Therefore, what is x1? Your x1 will be equal to minus 1 by omega C1. It should be negative. That I already told, right? That is what it is. If that is what is the case, I don't have space, but let me explain here only. Therefore, what is our beta network? Now, if you consider your beta network, then, okay, that part I'll explain later. Therefore, if you consider beta network, then what we have? To get resonant frequency, x1 plus x2 plus x3 is equal to 0. If you do that, what you will get? You will get what? Therefore, to find f0, to find resonant frequency f0. Therefore, what is f0? Your f0 is equal to 3 implies x1 minus 1 by omega into C1 plus omega into L1 plus omega into L2, L3. L2 and omega into L3 is equal to 0. If you take this omega this side, then you will get omega square is equal to 1 by L2 plus L3, right? 1 by L2 plus L3 into the C1. Therefore, resonant frequency F0 is equal to 1 by 2 pi L2 plus L3 into C1. This is what is our resonant frequency if you take X2, X3 are inductors. This is what is our resonant frequency, right? Now, case B, okay, X2 and X3 are capacitors. If they are capacitors, then tell me, what is X2? X2 is capacitor, then minus 1 by omega C2. Then what is X3? Minus 1 by omega C3. Then what is X1? 3 implies X1 is equal to minus of X2 plus X3. And we know that X2, X3 are negative into negative positive. Therefore, it will be inductor. And therefore, what is X1? X1 will be equal to omega into L1. Right? Now, to find, in this case, to find F0. What is resonant frequency? To find F0. Right? Therefore, 3 implies, what is X1? Omega into L1 minus 1 by X2. Omega C2 minus 1 by omega C3 is equal to 0. Right? Therefore, if you calculate omega into L1 is equal to, if you take 1 by omega common, then you will get 1 by C2 plus 1 by C3, then omega square, then you will get what? Omega square is equal to 1 by, right? This is 1 by C2 plus 1 by C3, that is what you will get it, right? 1 by C2 plus 1 by C3. Can I write directly? I don't have space here, okay? If you do it, you will get it, okay? 1 by L1 into some C equivalent, then F0 will be equal to 1 by 2 pi L1 into C equivalent. Therefore, what is C equivalent? Where C equivalent is equal to C1 C2 divided by C1 plus C2. You will get C equivalent will be equal to 1 by C1 plus 1 by C2. Like that you will get it. Okay, if you do it, you will get it. C1 C2 divided by C1 plus C2. Right? You write down. You know, this is nothing but, case A is nothing but Hartley oscillator. Case B is nothing but Colpitt's oscillator. That is what I am going to explain with respect to circuit. Then we will see. But in any case, this is what is, we found F0. We found F0. And what is the second condition? Therefore, total loop phase shift is becoming 0. Therefore, if both are alike elements, your open loop amplifier should give 180 degrees phase shift. That is what I will see. Then total loop gain must be equal to unity. Then this is 1. Then your A will be equal to, mod A will be equal to X3 by X2. That part I will explain. Okay. By considering different beta networks. Therefore, it is going to give you. Therefore, what is case 3? What is this oscillator? This is Hartley and Colpitt's oscillator. Actually, two types of oscillators are covered in one section. Therefore, Hartley and Colpitt's oscillator. Colpitt's oscillator. Okay, take it. Can I erase? Okay. Let's see one by one. Okay. I'm going to use this. Okay, minus a into x2 by x3. That is a star beta. Okay. Now the first one, Hartley oscillator. Hartley oscillator is nothing but, if you observe clearly, x2, x3 are inductors. Okay. Therefore, x2 and x3, they are inductors. And x1 is opposite to inductor, that is nothing but capacitor. Right? If you observe clearly, right, therefore if I use that, this is nothing but your amplifier A, then x2, x3 are inductors and this is capacitor. Therefore, if you observe clearly, this is what your capacitor and this is your inductor and this is also your inductor. Now, this is what is given to this. This is what is your C1, this is what is your L2 and this is L3. Can I write it like this? I think this is same. This is nothing but your amplifier A. Now I can say two inductors and having a capacitor, right? This is what is connected to ground, this is what is given and then this is taken here. Can I write like this? Both are same, right? This is what is split inductor. Okay, therefore the output of op-amp is L3, therefore this is L3 and this is L2, this is what your C1. Maybe once you know that this is C, L1, L2, that is also fine. Okay, but this is with respect to Z1, Z2, Z3, like that. Okay, this is what it is. Now we got to know the resonant frequency also, right? Therefore I don't have space, actually I want to complete here only. That is fine, that is fine. Okay, now tell me what is F0, the resonant frequency? That part I'll explain. Okay, let's see. What is F0? F0 is equal to 1 by 2 pi equivalent inductance into capacitance. That is what is equivalent inductance and capacitance, which is nothing but, in this case this is C1. Therefore where L equivalent is nothing but L2 plus L3 plus or minus 2M. What is 2M? The mutual inductance. Okay, that is what is mutual inductance. That depends on dot convention, right? If dot is here, current entering into the same dot, the magnetic field whatever you get from L3, that is coupled to L2 and then aiding to the self magnetic field of L2, then your mutual inductance will be aiding to each other. Then that is what is L2 plus M and L3 plus M overall plus 2M. If dot convention is opposite to the current flows through L2 and then L3, whatever magnetic field which you are getting from L3, that is coupled to L2 and then opposing the self magnetic field of L2, then your effective inductance of L2 will be L2 minus M, because that is what is decoupling your magnetic field from self magnetic field of L2. Therefore it will become minus M, for this also minus M, then you will get L2 plus L3 minus 2M. That we don't know, that depends on the dot convention. Therefore effectively we will have, because of mutual inductance, that is L2 plus L3 plus or minus 2M, which we need to consider practically. Done? Now for this, tell me, and we know that what is A star beta we got? We got A star beta is equal to minus A into, we got what? X2 by X3, right? X2 by X3. What do you mean by X2 by X3? X2 and X3 are inductors. Therefore, this is nothing but what? Minus A into L2 divided by L3. Right? To get total loop phase shift, therefore, this should be equal to 0 degrees. Therefore, your A should be, angle of A should be what? Angle of A should be, to get total loop phase shift, right? To get 0 degrees phase shift, total loop phase shift is equal to 0 degrees. That is nothing but what? Then your minus A should give 0 degrees. Therefore, your angle of A should be 180 degrees. Okay, this is what is A. And to get sustained oscillations, sustained oscillations, or I can say directly I can tell you, right, no confusion, just listen. I can say to get oscillations at F0, which we already calculated. Therefore, including everything, A star beta should be equal to 1. Therefore, what is that? Minus A into L2 divided by L3 should be equal to 1. Therefore, A should be equal to minus L3 divided by L2. This is what is your open loop gain requirement. Therefore, this is what is having angle of A should be equal to 180 degrees and magnitude of A should be equal to L3 divided by L2. This is what is your gain requirement. Okay. You can have just 1.01 or 1.1 or 1 or 1.3. That is what is enough, right, to have oscillations. Okay. And the frequency of oscillation is F0 is equal to 1 by 2 pi root over L equivalent into C1. L equivalent is nothing but L2 plus L3 plus or minus 2M. Okay, fine. Now this is what is Hartley oscillator. Then what is Colpitt's oscillator? Okay. Now case 2, Colpitt's oscillator. Okay. Now in this case, X2 and X3 are capacitors and X1 is opposite to it, inductor. Okay. Then tell me, what is your amplifier? If you take original one which we started, this is what your open loop amplifier A. Now Z1, X1 is inductor. Now these two are capacitors. This is L1, C2, C3, output of it is connected. Therefore, this is nothing but what? Open loop amplifier A, and it is having two capacitors and having inductor in parallel. Then this is what is your, and this is your split capacitor. This is C2 and C3, and this is your L1. And we already calculated resonant frequency F0 is equal to 1 by 2 pi L1 into C equivalent capacitance, where C equivalent is equal to C1 C2 divided by C1 plus C2. This is what your resonant frequency. Okay. And coming back, the same thing, coming back to A star beta. Therefore, we know that A star beta is equal to what? Minus A into X2 divided by X3, right? Then if you substitute, what you get? Minus A into, what is X2? X2 is nothing but capacitors. Then you will get C3 divided by C2, right? Now to get oscillations at frequency F0, right? Then what is your A star beta? Your loop gain, effective loop gain, total loop gain should be equal to 1. Therefore, your minus A into C3 divided by C2 should be equal to 1. Therefore, A should be equal to minus C2 divided by C3. This is what is your open loop gain requirement. Therefore, it should have angle of A, your open loop amplifier should have 180 degrees phase shift, and magnitude of A should be equal to C2 divided by C3. This is what is the requirement. C2 divided by C3. That is what it is. Okay. And this is what is your frequency of oscillation. This is what your F0. Okay. Basically, this is tank circuit if you observe clearly, right? But here, in the case of Hartley oscillator, this is what your split inductor, and this is what people call as split capacitor. Okay. Almost the session is over. In this session, you can just take it. Then I will give you figure of merit in the next session. Okay. In the meantime, you try to complete both. It is with respect to beta network specifically, then Hartley oscillator, then Colpitt's oscillator. See, you can take X1, Z1, Z2 also alike elements, but the open loop amplifier phase shift requirement is 0 degrees, right? Then we should have op-amp and all those things, right? But practically people go ahead with this solution. Think about it, why it is effective, okay? That part we will see, that is what is figure of merit. Done. You take it, then I'll continue in the next session. I hope this is not creating any confusion. Actually both are same, but I am just applying. This is the generic one, but applying for inductors and applying for capacitors. That's it. Okay. Continue. Then we will see the figure of merit or observations part for RT and Colpitt's oscillator in the next session. Okay. Thank you.